Today in this class, we will study the different types of quantization techniques. You know that quantization is the second step in PCM modulation. After sampling, the signal is quantized to its nearest quantization level and then is digitally encoded in a PCM system. Okay, so there can be two types of quantization: uniform quantization and non-uniform quantization. If you look at the diagram, in uniform quantization, we can see that the quantization levels are equally divided. Okay, so for each sampled level, the quantization level is equally divided, or they are equal, and we are getting a uniform stair-step waveform here. Okay, but in non-uniform quantization, the quantization levels need not be the same. That is, the quantization level varies depending upon the input signal amplitude. Okay, so if you look at the diagram, we can see the quantization levels are different for different signals. In actual practice, the quantization level will be smaller for smaller amplitude signals, and the quantization amplitude will be larger for signals with large amplitudes. Okay, now in actual practice, such a quantizer is very difficult to achieve. That is, a quantizer with varying step levels or a quantizer with varying quantization levels is difficult to achieve. So what is done is, to achieve non-uniform quantization, we use a process known as companding. So companding is nothing but the process of compressing and expanding. The words compression plus expansion is called as companding, or companding is the abbreviation of the two terms compression and expansion. So in transmitting side, the signal is first compressed, then it is quantized uniformly with the help of a quantizer and is transmitted through the channel. In the receiver end, to restore the signal has to be expanded. Okay, so compression at the transmitting side and expansion at the receiver end. Okay, so what is done is, the smaller amplitude signals are amplified and signals with large amplitude signals are compressed. Okay, and after performing compression, the signal is quantized with the help of a uniform quantizer, and the signal is modulated and is transmitted. At the receiver end, to restore the signal is expanded. Okay, so this is the characteristics of a compressor, and this is the characteristics of a receiver. So this is a very important topic as far as the exam is concerned. Now let us see what are the building blocks of such a companding system. Okay, so we have a compressor. The input is first compressed, then it is uniform quantized at the transmitter end and is encoded and finally transmitted through the channel. And we have an expander to restore the signal. Okay, so an expander is actually performing the reverse operation as that of a compressor. Okay, so the characteristics of a compressor and expander will be equal and opposite. So if we combine both the characteristics, the compressor and expander characteristics, what we obtain is a straight line. So this is the straight line of a compander. So look at the diagram. This is the characteristics of a compressor and this is that of an expander. So if we compare, or if we combine both the characteristics, we will be getting a straight line. So this is the input-output characteristics of a compander. Okay, now why companding is done? Why companding is done? So companding is done to minimize the noise and distortion and for reducing the interference and crosstalk. So in almost all the practical telephony systems and audio application that uses PCM or pulse code modulation, the signal is companded like this. Okay, so we'll continue with a different topic in the next class. Thank you.